So welcome everyone and a very good morning to today's class. And today we will try to wrap up this longitudinal waves and wave motion. Up till now in the last class, we had seen what happens in an open organ pipe, what happens in a closed organ pipe. And if I could recollect that, if you remember, on the closed end, we have a node and the open end we have an antinode. We have also seen that at node the amplitude is zero, the particles do not oscillate, the distance between one node and antinode is lambda by 4, between two nodes it is lambda by 2. Do we all recollect that? Yes or no? We have also seen that the first wave is known as the first harmonic. The frequency of the first harmonic is also known as fundamental frequency. It is known as F1. Now let us continue on with this discussion and move on to our heading for today. And what is the heading for today? As I told you, the heading for today would be beats. We are going to understand beats, but before going on to beats, what we are going to do is understand end correction, and we are going to understand end correction for an open pipe. We had seen end correction for a closed pipe, and what happens in a closed pipe. A closed pipe is closed at one end and it is open at the other end. What we had seen in a closed pipe as well as in open pipe, at the open end, as you can see, you always have an antinode coming at the open end. Yes or no? You can see here, wherever we have a open end, we have a antinode coming. But we had also seen that if the pipe is open or closed, we had seen it for closed pipe, the antinode does not occur exactly at the end. Do we remember this? It occurs slightly outside. It occurs slightly outside at its end, and we add one end correction to the length of the pipe. And if you remember it correctly, that end correction E was given as 0.6 R. Do we recollect this? Can I have some raise hand that we recollect this? 0.6 R, where R was the radius of the pipe, bacha. Now remember, in closed pipe, we had one open end, and therefore we added for a closed pipe, the end correction was L plus E. We only added one E because it was open at one end. Here, when we have an open pipe, and when I say an open pipe, it is open at both ends. The end correction will happen at the both ends, and therefore for an open pipe the end correction becomes L plus 2E, whereas if I talk about the closed pipe, and the blue one is for the closed pipe, the end correction is L plus E. The simple reason being, in a closed pipe we have only one open end, in an open pipe we have two open ends, and therefore the difference between the two. Please note this down point very carefully, beta, because this question has been asked many a times in the exam. So I'll give you a minute to note this down. The end correction for open pipe, the end correction for closed pipe, you can write them together so that you can remember them easily. I'll give you a minute to do that. Let us move ahead and jump on to the topic that we were supposed to do, we are supposed to do today, and that is the topic of beats. Now you would have heard this term beats when you would have talked about music. When you are listening to songs, you would ever, yeah, this beat, the beats of this song are very good. The beats of this song are not good. I don't like his beat. Now we use this term beat very often, but do we understand the meaning of the term beat? Now remember, when I talked about interference, when I talked about interference, interference was superposition of waves in space. In interference, what happens? At some point, you have maxima, at some other point, you have minima, and the points of maxima and minima remain fixed. They do not change with time. So we call interference as superposition of waves in space. Do we understand this? Now imagine you are standing at a place and you are watching and you are hearing interference of sound waves. So if you are standing at the position of maxima, you will always get maxima. If you are standing at the position of minima, destructive interference, you will always hear minimum sound. But one exciting thing can happen. If the sound waves that you are hearing are of slightly different frequencies. Remember, for interference, we have noted that the sound wave or any wave should have the same frequency. Do we remember this? They should have same frequency, nearly the same amplitude. They must be traveling in the same direction. Then you have interference. Their phase difference must remain constant with time. That was the basic criteria. What was the basic criteria? The phase difference must remain constant with time. But if I have sound, the source having slightly different frequencies, not not very different, slightly different. Say for example, one source has a frequency of 60 hertz, the other has a frequency of 60.1, 60.2, and so on. If I have two sound sources, say for example, I am playing a guitar, dung 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 dung. You might have gone to a music concert. Might not have gone at this stage now, but once you get into a college, medical college, engineering college, in college you have college fest. Do you know college fest? One part of a year, this college organizes a college fest where students from other colleges come. You have all sorts of cultural activities, song, dance, and all activities, and people mingle with each other. That is the time where you enjoy your life. You have college fest. In college fest, you have all sorts of cultural activities. You also have live concerts. I'm from engineering college. We used to have live concerts. We used to have rock bands coming and playing all sorts of stuff in my college. If you have seen a rock concert or you have been to any live show, or for example, you just heard a song and someone is playing guitar, gun, 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 and someone is also playing a violin at the same time, and someone is beating the drums. All these, see, nothing happens by mistake. If you like some sound, if you like some beats, they are produced by frequencies which are nearly similar. So someone who is playing the guitar and someone who is beating the drum, they are not beating it randomly and then you get good sound. They are beating it in such a way that they produce sound of slightly different frequencies. Now, what happens is when you have sound of slightly different frequencies, if you are standing at one point, you don't always get maxima. Sometimes you will get maxima, sometimes you will get minima, sometimes you will get somewhere between maxima and minima. So you will experience all types of superposition. You will experience all types of superposition, and my current has gone. So what I'll do is I will switch to my mobile connection. I hope you can see me. I'm still audible. I'm still visible. Yes. So my internet connection is stable. Just give me a moment. I'll just put the door on. I'll just open the door. Just a minute. Okay, I'm back. You can still hear me? So what I was saying was, if you are listening to various type of sound, musical instrument at it, and not moving and just sitting at one place, at some times you might hear maxima, at some times you might hear minima, at some other time you may hear anything between maxima and minima. So sitting or standing at one place, you are getting all sorts of combination, all sorts of superposition, and your maxima and minima keep on changing with time. The maxima and minima keep on changing with time, which is what is written here. The intensity of sound, the intensity of sound. Oops, what is wrong with this fellow? Everything goes wrong when it has to go correctly. What has happened here? Okay, something wrong. Okay, so what do you see is intensity of sound rises and falls periodically at the same point. That means waves are interfering in space actually, but at one particular point, you can hear all maxima, minimas, and all types of intensity. This rise and fall of sound intensity at one point is known as a beat, and in short you can call beat as interference or superposition in time. When waves are superposing in such a way that at one point you will hear maxima, minima, and the intensity keeps on changing, this type of superposition of wave, and it will only happen when you have two sound waves of slightly different frequencies, equal amplitudes. So you should remember all these points. Number one, slightly different frequency. Number two, they must have equal amplitudes. Number three, they are traveling in the same direction. They are traveling in with the same speed. If these three conditions are met, you will have interference in time. At one point, you will have all sorts of intensity. This phenomena is known as beats. Do we understand this? Can I have some reason that we understand this? Now remember, this is an unstable interference. Why it is unstable? Because the phase difference will keep on changing with time. Remember, in interference, phase difference was constant. Here phase difference will keep on changing because your frequencies are different. That is why the resultant amplitude and intensity will change from maximum to minimum at a given point. Rise and fall from maxima to minima at one point is known as one beat. Do we understand this? So when you hear the highest intensity and you hear the lowest intensity, from one rise to one fall, that is known as one beat. Time between two beats, time between two beats is between two consecutive rise or two consecutive fall is known as beat period. Do we understand this? What is the beat period? Between two rise or two falls, whatever time it has taken is known as beat period. Number of beats per second is known as beat frequency. Do we understand this? Number of beats per second is known as beat frequency. I will give you a minute to note this down. And I'll be back. So we have seen beat is interference in time. Now remember, if the frequency of the waves will differ too much, beats cannot be observed because resultant intensity will change very fast. So we don't want the frequency to be differing by a lot, because then the beat frequency would be very fast, and if the beat frequency is very fast, we will not be able to observe or hear any beats, and that is why light beats are not possible because the frequency differs by a lot. You cannot observe beats in light, but you can observe beat in sound. What is the limit? Not more than 10 hertz. If one is 60, the other one should be 50 or 70. If it is more than that, we don't see, we don't observe, we don't hear any beat. How do you find the beat frequency? That is pretty damn simple. If the frequency of the waves are N1 and N2, and N2 is smaller than N1, the beat frequency will be given by N1 minus N2, very simple. And the time period or the period of beat will be given by 1 by N1 minus N2. Is it clear to all? Very simple formulae. I'll give you a minute to note it down. Okay, then we come to the next slide. And remember, you should note down all these points carefully. What are the necessary conditions for beat? They must travel in the same direction. Amplitude should be nearly equal, same speed, same medium, and the difference of frequency should be small. What are the application of beats? Remember these application because any of these can come as a question. To detect gases in mind, to compare frequency of two tuning forks. You must have done this experiment. To tune the radio station, to tune musical instrument, you might have seen guitarist, sitting with the guitar and doing something that is known as tuning, that is done with beats. To manufacture oscillators of small and stable frequencies. Remember all these because any of these can come as a question in your exam. I'll give you a minute to note it on. That takes us to the last part of this discussion, where we can find or determine any unknown frequency of any tuning fork with the help of beat. I've seen this question come many a time, so please remember how it is to be done. What do? We will have a tuning fork of unknown frequency F2 or N2. It will be oscillating with a tuning fork of frequency N1. This N1 will be known. And let us assume that N or F number of beats are produced. Now, the unknown frequency N2 would be given by this formula N1 plus or minus N. For example, if the value of N1 is 50 and I hear 10 beats per second, that is number of beats per second is 10, then the unknown frequency N2 can be anywhere between or would be anything between 50 plus 10 or 50 minus 10. So N2 can be 60. Why I'm writing 64? N2 can be 60 or it can be 40. Do we understand this? Yes or no? No or yes? Well, great. But now the problem is we don't know the exact value. Out of these two, one would be the value of beat. One will be the value of the unknown frequency. Now, how do I go further? Now, there are two ways in which I can go further. Way number one is wax will be applied to the tuning fork of unknown frequency. In first method, what we are going to do is we are going to apply wax. We are going to apply wax. What happens if you apply wax to the unknown frequency? Its frequency will decrease. It becomes heavy, its frequency will decrease. That is what you can see on the screen now. I forgot to bring up the screen. So basically what I'm saying is if the known frequency is 50 and the number of beats is 10, the unknown frequency can be anywhere between or anything between 60 and 40. Which one of this is correct? To find out that, we apply wax on the tuning fork of unknown frequency. Because of this, the frequency of the tuning fork will decrease, and again it is made to oscillate with the known frequency. Now, If the beat frequency increases, then N2 will be equal to N1 minus N. Now, it might be difficult for you to remember the formula, but instead of remembering the formula, just use some common sense. Now, for example, I apply wax on the unknown frequency tuning fork and my beat frequency increases. Now, if my beat frequency increases, remember what is going to happen. The frequency of the unknown tuning fork has decreased, but that has led to an increase in my beat frequency. If the value of the unknown frequency was 60, after loading with wax, it might become 59. If it was 40, after loading, it might become 39. Now, if it becomes 59, the known frequency was 50, the number of beats or beat frequency should increase. Do we understand this? If it was 60, it comes down to 59, then beat frequency or number of beats would decrease. In the first case, they were 10. Now you will get 9 beats. So the number of beats or beat frequency will decrease. But if it was 40, then the new value now becomes 39 and the number and the beat frequency increases. This is how you can understand this. If the beat frequency increases, then the lower value would be the actual value. Do we understand this? Do we understand this? Yes or no? No or yes? That is how you will remember this. If you can't remember the formula, you can just apply this common sense. On the other hand, if the beat frequency decreases, which is the case here, the beat frequency from 10 has become 9, then you will take the upper wala value N1 plus N. If the beat frequency remains unchanged, then you will again take the upper wala value. This doesn't happen. You don't encounter this case. We don't consider this case. So basically, you will have two cases coming here, whether the beat frequency will increase or whether the beat frequency will decrease. If the beat frequency increases, you will take the lower value. If the beat frequency decreases, you will take the higher value. Do we understand this? Yes or no? No or yes? I'll give you a minute to note this down. Then we can do the opposite of that. Instead of loading it with wax, what we can do for the unknown frequency wala tuning fork, we file it. We file it. When we file it, we make it lighter. When we make it lighter, its frequency increases. So, if the frequency was 60, the frequency now may become 61. If the frequency was 40, in the previous case, it becomes 41. Do we understand this? Yes or no? We got two answers, whether the answer is 60 or whether the answer is 40. In first case, we have done it with wax. Now we are doing it with filing. So now what will happen, bacha, is that what will happen here is the frequency of the tuning fork, unknown frequency, will increase. It will become 61 or 41. Now we look at how much is the beat frequency. If the beat frequency increases, now 61 and 50, the beat frequency will become 11. It has increased. That means your correct answer is the higher value. If the beat frequency decreases, then your correct answer is the lower value. Do we understand this? Yes or no? No or yes? I'll give you a minute to note this down. Light has also come. I'll give you a minute. Note it down. Okay, then we move ahead, and these are the two important points that you must note. I've seen question of this coming in your exam. If n number of, remember n is not the beat frequency, if n tuning forks are arranged in series, such that each tuning fork produces capital N beats with the first one, and the last tuning fork is P times the first tuning fork. Then the frequency of the first tuning fork, this is simply maths. It might sound very ajeeb sa, but if you can take, say, let us for example, there are 5 tuning forks each, and they are producing 10 beats per second with the first one, and this is, let us say, 6 times the frequency of the last one is 6 times the first one. Then what is the frequency of the first tuning fork? This is the answer. You can just remember it. Do we understand this? If the tuning forks of frequency n minus 1 and n plus 1 is oscillated together, 3 tuning forks oscillated together, then beat frequency is equal to the difference of frequency of the consecutive. So n minus 1 and n, whatever is the difference in frequency, that will be the beat frequency. So the beat frequency in this case would be, and these are very, very important points that I'm telling you. Please note them down. I'll give you a minute to do it. Well, then that takes us to almost to the end of this particular section. And the last thing that remains is, how do we find the velocity of sound in air? Well, we already know the formula, gamma p by rho ka root, but it may not be so easy to calculate gamma, p and rho if you don't know it. Well, you can do a simple experiment if you want to determine the velocity of sound, and there are 2 experiments that we are going to do. Just have to see the diagram. The first one is known as the resonance tube method to calculate the velocity of sound. What is this resonance tube method? You have a column or a resonance tube, which is nothing but a pipe which is closed at one end. A simple form is given here. This is water, and you can adjust the level of the water surface. Now you have a tuning fork here of known frequency. This is struck with a copper, with a rubber or cork hammer, and it is held near the mouth of the tube. And you adjust the water level so that you have a resonance. And resonance means the frequency of this tuning fork is same as the frequency that we are getting from the organ pipe. Do we understand this? This air pipe, this air column, which is closed at one end, is going to have some frequency of its own. We have seen the frequency. For a closed pipe, you only have odd frequencies. Do we remember this? First harmonic, third harmonic, fifth harmonic. That is what we have. When resonance happens, the frequency of the tuning fork and the frequency of the air column. Remember, this is the first harmonic and this is the third harmonic. Do we remember this? That's it. Well done. Well done. So, what we have to do is what is given here, short theory. To get resonance, both the frequencies must be same. The fundamental frequency is given by V by 4L. What happens is we will find two consecutive positions where we get resonance. Those two consecutive positions, the frequency of that first position will be given by this formula, and NT will be, you will not be able to determine the value of NT, but you will find the next possible resonance and then you will subtract them. So the final formula will come. Remember, you might have to adjust for end correction as well. Normally the end correction is not given. So you can find out the frequency Remember, you will look for two consecutive resonance and you can find out the frequency using this formula and wavelength using this formula. V is the speed of sound, and then you can find out the frequency of sound. If you know the frequency of sound, you can find the speed of sound. That's it. V upon 2 times L2 minus L1. Why 2 has come? Because between two resonance, you will get the first harmonic, third harmonic, or third and fifth, or fifth and seventh, or seventh and ninth, and ninth and 11th, and 11th and 13th. The difference between these two resonance in terms of frequency or in terms of wavelength would be lambda by 2, and therefore you have this formula. Do we understand this? Can you remember this formula for resonance tube? Simply, when you see resonance tube, you just put this formula. L2 is the second length, L1 is the first length, and we have this formula. Can you do that for me, bacha? I'm not seeing raised hands. I'm getting confused. This is the formula for determination of speed of sound or frequency of sound using resonance. This frequency of sound will be same as the frequency of the tuning fork and the beats that you hear. You will know this. From here, you can calculate the speed of sound. We will do example, don't worry. Right now, just note it down. Our discussion, and let us solve some question. And this is the first one that comes on you. For an open organ pipe of length L, the wavelength of the fundamental note. These are the questions that are going to come, bacha. The more you practice, the better you are going to become. And I'm what waiting for your answers for this one. This is question number 25, taken from your sheet, and I'm waiting for your answers. What is the answer for this one? Tell me first. It's an open organ pipe. Remember, open organ pipe, you have antinote at open ends. If you remember the configuration, if you remember the diagram, you should be able to give me the answer for this one. And what is the answer here? See, you have forgotten. That is not a good sign. Forgetting is not good. I must tell you that. I can't see your raised fingers because sunlight is coming from the other side. So you'll have to do it on the side of the wall where I can see your fingers correctly. See, I might be omnipotent, omnipresent, but my eyesight is weak, and that is the problem. Three is wrong. Remember, for an open organ pipe, you have antinode at one end, antinode at the other end. Distance between two antinodes is lambda by 2, bacha, not lambda by 4. For a closed pipe, you have one node and one antinode. The answer is 4 lambda. For an open organ pipe, the answer for lambda, the length is L by 2. So the answer for lambda becomes 2L. Will you remember this? Will you remember this, bacha? Or shall I show you the sheet where we had seen? Okay. If you have any doubt, bacha, please look at the sheet, and I will show you a part of that sheet there that might help you in remembering it correctly. I can understand the problem of not remembering because I have the same problem. So I can very nicely resonate with your feelings that sir, I can't remember it. And I always keep on telling my students how to keep on remembering things. Well, the best way to remember things is you have your collage. Wherever you sit to study, you put a big collage, a thermocol, and you put all your formulas pinned up there. And wherever you are sitting, you have a look at the formula. Remember, this is the open organ pipe. Yes or no? No or yes? I showed it to you just before the class. You have one antinode and one antinode. The distance between the two antinodes is lambda by 2. Lambda by 2 is equal to L. So your lambda becomes 2L. Do you recollect it now? Well, you can forget things. I can understand that, but you must be prepared You must be prepared to remember them and find out ways in which you can increase your remembrance. This is the next question that is going to come. The wave produced in a resonating air column. You've seen that resonating air column. What type of wave it is? It is progressive, longitudinal, stationary, longitudinal. The other options are definitely wrong because sound wave is not transverse at all. It is longitudinal. So both the other options are definitely not looking correct. Which is the correct option? Obviously, it is from A and B, and we know the answer. What is the answer? It is progressive or it is stationary? It is definitely longitudinal. Which one is the correct answer, bacha? Yes, this time the answer is B. You don't have progressive waves, you don't have moving waves in a air column. You only have stationary waves in a air column, and that too of longitudinal type. Comes the next one, and let us hope that I can get an answer out of you for this one. Beats are a result of constructive and destructive interference? Huh? No. Option number 4, I only saw 3 fingers. My eyesight. Obviously, it is 4, not 5. 5 is not an option here. Just because you do 4, I see 3, that does not mean that you do 5, I will see 4. Right? It doesn't work that way. The eyesight doesn't work that way. Okay. Let us move on to the next one. Now you are a pianist. I don't know how many of you can do that, but piano is one of the most expensive instruments to buy. So even if you are a pianist, you might not be able to afford one piano right away. Might have to go to places to play the piano. Well, two adjacent piano keys, dung, 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 are struck simultaneously. Now you will say, sir, we don't know piano. How can I solve this question? Remember, it has got nothing to do with piano. It has got to do with the number of beats that the piano produces. The notes emitted by them have frequency N1 and N2. See, that is how this pianist, Adnan Sami at one point in time was the fastest pianist, right? The faster this pianist moves his finger along the board, the better the music it sounds. Do we understand this? Now, that is the theory behind it. That is the physics behind it. How much is the number of beats? And the more the number of beats you hear, and you feel, wow, 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 what a marvelous piece of piano. Question number 46 is on your way, and I am expecting an answer. Which one is the number of beats heard per second? And the answer is, Array, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3 is free, and 3 is the correct answer. That is correct. Well done, bacha. We are going on the right thing. So that is how the faster the pianist plays. That doesn't mean that if the pianist is playing slowly, the music will not be good. The pianist knows how to indulge yourself into that mystery of music. Music is physics. Physics is music, and music is divine. Next one. Question number 39. The correct formula for determination of velocity of sound in the resonance tube is. Let us see. Then give me the answer for this one. A, B, C, D. 1, 2, 3, 4. I'm waiting for your answer, bacha. Patiently waiting. It is definitely N1 minus N2. Right? No, sorry. I was looking at a different question. 2, 2, 2, 2. I hope you have not seen the formula and then told me the answer. 2 is definitely correct. We have seen that N is V by 2 times L2 minus L1. Here they have written V in terms of N, and that is how you get your answer. Are we getting there? Yes or no? No or yes? Let us do one more on this tuning fork, because tuning forks are in fashion these days, and NTA may give question on tuning fork because this is an experiment that you can do in a lab, so you can actually see this thing happening. A fork of frequency 100, so that is the known frequency, is sounded with another fork B. The number of beats is 102, is 2. So from there you can tell me which two options are possible. Which two options are possible? Either, tell me which two options are possible. Only two options are possible, whether it is 102 or whether it is 98. Yes or no? No or yes? On putting some wax on the prong of B, so I'm loading it, the number of beats reduced to 1. Which is the correct option? And the answer is, apply some common sense and you will get your answer. You might not remember that formula. You will apply some common sense and tell me what is the answer. And the answer is definitely 3. Well done, bacha. I don't have to explain it, but we'll do one more on this category, and then we will call it a day for this one and move on to some greener postures in the next lecture. So number 48 is what is waiting for you, beta. Two tuning forks A and B are sounded together. They produce 4 beats per second. That is good. A is slightly loaded with wax, remember. Then they produce 2 beats when sounded again. The frequency of A is 256. So now right away you can tell me only two options are possible. Which are the two options, bacha? Which are possible? The two options which are possible are only 260 and 252. Now A is slightly loaded. The number of the frequency becomes 2. The frequency has decreased. A has been loaded. So A ki frequency will reduce. 256 might become 253, to 255, 254. Which is the correct option? The frequency of B. It does not require physics. It requires common sense, and you have gathered a lot of common sense in the past days. And that is answer 252 is the correct answer. So beta, with this, we come to an end to this intriguing chapter of longitudinal waves. We have broadly discussed all types of waves, but specifically we have dealt with sound waves. Sound, that is what you are hearing right now. The fan is producing sound. I am producing sound. We have seen this sound. We have found out the velocity of sound. We have done a lot of things. We have seen resonance. We have seen vibration of air column. We have seen standing waves. We have seen stationary waves. Everything is done. We'll finish this lecture here. I'll give you 5 minutes to again go through everything from transverse waves to longitudinal waves. Everything I'll give you 5 minutes. The next lecture, we will go ahead. The last topic of this chapter, the chapter is wave motion, and the last topic is Doppler's effect. Doppler's effect. That is the next topic, the next lecture. Give you 5 minutes. Go through this. We'll be back with the next lecture with Doppler's effect. I request you to get your sheets. Doppler effect is what we're going to do, and probably we might end up finishing the entire Doppler effect as well. It's a very small topic, but a very effective one. In the next class, in the next lecture, 5 minutes, I'll be back. Take care and study.